It's a pleasure to be here today. I'm going to give you an insight into what we get up to in the design studio at McLaren Automotive and how we're using all the technologies that you're seeing here today to actually add value to our design process. But before we start, I'm just going to give you a little insight into a typical day in the studio. So this is me, Mark Roberts. I'm head of design operations at McLaren. I've been at McLaren a very long time, actually, over 20 odd years now. I joined to do the F1 road car. I was actually one of the founder members on that team. I always say we knew it was something very special when we started, but none of us had any idea how legendary that car was going to go on to become. But the really key thing is the DNA in that car flows through everything we do today at McLaren, and you'll see that in some of the images I'm going to show you and talk through later on. My day job, really, one of the key deliverables for me is to make sure we've got the right people and to make sure we've got the right tools to deliver the cars, and tools is a big part of what I want to tell you about today. So, back in the day on the F1, it was never actually designed to be the fastest car. We just happened to do that by default. It was designed to be the ultimate driver's car. And it was that complete obsession with lightweight and purity of design and just optimizing everything to the nth degree to create such an awesome product. And the other thing that I think is really important to understand is, I think what makes McLaren cars unique is the combination of craftsmanship and cutting-edge technology. And I'll show you how we thread those two things together too. So my original background back in the old days was using pen, ink, paper, pencils, and doing technical illustration. But actually, I see that as going full circle now, because what I used to do with these sort of drawings was show someone what something was going to look like before it actually existed in the real world as a physical entity. So guys used to be over my shoulder, engineers, waiting for me to actually construct something to go, that's what it's going to look like. It was in the days when they worked in like third angle projection and first angle projection. And it really is true. It's what we're doing now with contemporary software to do visualization and using virtual reality. It's showing you what something's going to look like before it actually exists. So I'll take you very, very quickly, because I don't want to go overrun with my time. I'm going to take you through a little bit of background about McLaren, straight through the design process, and then I'll talk about some of the tools we're creating. This is our goal, to be the iconic sports car company. We've got quite a track record already, a portfolio of cars that are out there on the street, but we've got a lot more in the pipeline. Typically, we're looking at 8 to 10 models. Well, we're working on 8 to 10 models in parallel in the design studio, which is quite a tall order. This is home. This is Norman Foster Design Factory that was built in 2010. That's on the right, and then we built the manufacturing facility over on the left. We're pushing out around 22 cars a day at the moment. We max out at about 6,000 cars a year. And this is the scary bit for us. Track 25, our business plan, is promising 18 new cars or derivatives by 2025. So we're into car 4 at the moment that we've delivered, but we've got a lot more cars to deliver, another 14. And to be perfectly honest, that's the driver for me and for us at McLaren to find faster ways of designing cars, delivering cars, and basically to speed up the process. But then the caveat for me is I've got to maximize the creativity, or at the very, very least, not lose out on any of the creativity for the design team, which I think is quite a tall order. So, whoops. So we go through the series of cars. We have Sports Series, Super Series, and Ultimate Series. Very briefly, this is like, it feels wrong to call it entry level, but it's the most sort of daily drive type car that we produce. It's designed so that it's all designed really more around fun. Then when you go up to Super Series, things start to get a bit more serious. And also you've gone from, in dollars, you've gone from like $300,000 up to like $400,000 to $500,000 with this sort of car. But it starts to become more driver-focused, more track-focused. The instrumentation starts to wrap around the driver more. It all gets a bit more serious. When you get up to Ultimate Series, you're looking at $2 million plus cars. And these are, for me, they're kind of like fighter aircraft for the roads, for the street. They're really mostly track vehicles that are street legal. We have started doing, like with Speedtail in the bottom right, more GT-type cars, which is super high-speed, cross-continental driving or across the US. These are really dialed up to the max, these cars, and you'll see a little bit more about that design language when I carry on. So, McLaren design. This is our mission, breathtaking products that tell the visual story of their function. Nature's the ultimate designer, and we try to emulate nature in everything we do. The simplest designs, the purest designs are always the best. And it's that whole form follows function simplicity that we're searching for. The guy at the top's the fastest thing in the sky, designed by nature, Peregrine Falcon. He can do almost 200 miles an hour when he's in full dive. No surprise at all that we mimic him absolutely 100% to create, the most sophisticated stealth aircraft there. And it leads us into the kind of mindset of these design principles. So we have the first one being everything for a reason. The surfaces, so on the left, like with the shark, the surfaces have to look beautiful. That's a big deliverable for us. But at McLaren, they have to manage airflow over the car, under the car, and through the car. Just like when he's swimming through the water, it has to manage what's around him. It's all about performance with us, but beauty and performance. The next one is truth to materials. We learn a lot from Formula One. Formula One technology, we're the pioneers of composites and carbon fiber. We've been doing it since 1981. Every single car we produce is underpinned by carbon fiber monocoque. The panels on most of our cars are some sort of composite material, and it allows us to create these really complex, beautiful sculpted surfaces managing the airflow, and we can only really do it with composites. The next one is outstanding aesthetics. The volume of the car, we want it to look like it's doing 100 miles an hour when it's static. We want it to show the power. We want the poise of the car to come across in the volumes, and the stance of the car as well. We want it to look powerful and it just look fit for purpose. The next one's engagement. From a customer or anyone in the street seeing the car, we want them to have like a sense of occasion when they see our car. They see it static or driving by. You walk up to it, you open the doors. It's a sense of occasion with these beautiful dihedral doors. But more importantly, when you get in it, we almost want people to feel like they're the final component getting into the car. You want the hairs on your neck to stand up, and it's a real sense of occasion. That's that kind of driver engagement. And probably the most important one that really kicks off some of the things I'm talking about today is always brave. We genuinely never stand still. We're always looking for a better way of doing things. And that goes back to our racing days with Formula One. We're constantly trying to find a better way of doing something. So the next set of pillars, we call these are the kind of rules around how we design our cars. So the first one we would say is shrink wrapping. I always like to think I've put on a little bit of weight since we took this photo. But we literally shrink wrap the bodywork around the cars. And again, from sports to super to ultimate, we dial it up more and more to actually suck it down onto the structure underneath. Then with layering, it's a similar process. We need to make the car breathe, so we actually start peeling away some of those layers. The more powerful the car gets up to an Ultimate Series car, you need to peel away even more of the body surface to suck air in and manage that airflow. Visibility, we have an expression we've started using more recently called blurred boundaries. We actually want the inside of the car and the outside of the car to become almost one. And we really pride ourselves on giving maximum visibility from the glazing. We almost want it to be like an aircraft cockpit. You can have all the power in the world, but if you can't put that power down, then if you haven't got the confidence of driving, you won't be able to put that power down, basically. So we want to give you maximum visibility when you're driving the car. Intuitive user experience, our HMI is becoming more and more complex under the skin, but we want it to become more visually clean and minimalist for you, the users of it. And that's something, again, I can tell you a little bit more about. And one of my favorites is functional jewelry. Everything has to be functional 100%, but there's no excuse for anything on our cars not looking beautiful. So, I'll take you through the process. We start off with 2D sketches. We're looking way, way ahead, probably 10 years, 15 to 20 years ahead, and we're looking at forms that could be influenced by almost anything. And we start to look at these volumes and forms in the early stages and start to put them on a roadmap. Then when a program starts to come to life, we get a marketing brief, we get some engineering hard points, we get some aerodynamics targets, and they all start to have an impact on those initial sketches. Engineering hard points are a fundamental part of the design process. We can never just, as a design team, we can't just lock ourselves in a room, create something beautiful and sexy and say, there you go, guys, make that work. We have to work hand in hand with the engineers and the manufacturing guys, the quality guys, and the legal guys, all of these vision angles and all of the constraints that now apply to any street car. So we have to respect them at all times when we're putting together the initial concept. Exactly the same with the aero. Like I said earlier, we have to really think about the open areas where we're sucking in air, the areas on the rear deck where we're throwing out dirty air, and that all has to be managed and taken into account. So once the process really gets going, we'll have 4 designers typically working on the exterior themes. They're all fiercely in competition with each other. They want their car to win. We're still in 2D. We're still sketching just Photoshop. We're using pens, pencils, sketches, scanning things in and so on. But it's a really competitive time. And what we want to do is go as quickly as we can from, say, 20 themes like this, down to 10, to 5, to 2, and ultimately to 1 as soon as possible. This happens over like 4 to 6 weeks. There's a typical worksheet where the guy has obviously looked at some aero, he's probably been to a classic car race at the weekend, he had a bit of influence from that. All sorts of things are factoring into these sheets. And these are giant posters that are on the walls in the studio, basically, through the process. Another week or so starts to mature that sort of activity. And then, when we get down to that person's individual theme, still in competition with the other guys, the car's really starting to get its personality and it really comes across and we're starting to pin down those points. And then we go to 3D. This is when it really starts to change. It's only when you start to put the model into 3D that you know if it works or not. You can cheat a little bit in 2D, you can change things, you can make it look cooler than it actually is in reality. Once you get into 3D, there's no escape from the physical facts of what you've designed. This always used to be a really challenging stage because you have to sit with a CAS modeler like Lisa here. All the designers have their favorites, and the best relationships are almost telepathic. They always want that guy, that person to work with. It takes a week to 2 weeks to turn a 2D sketch into a 3D model. And they know that the person they get on with that sort of telepathic relationship is going to get the best out of their design, and the chances are they're going to win, and that's what they want. That's always been a difficult stage to do that. So this is something new. Some of you may have heard of this. I came up with the idea 3 or 4 years ago, the initial concept. We've been using VR for that long. We get loads of value out of it. But what I realized very quickly was there was nothing out there for designers. There were no creative tools. We got good value analyzing data, sitting in a virtual buck and so on. But I could see there was a huge opportunity to empower a designer to be able to put on a headset and actually start sketching something in 3D using VR. And I invited a guy over. A guy basically looks after a team of computer games designers. We sat down with one of them. we spent an hour or so going through it all. I kind of did a brain dump of what I wanted the tool to be. The long story short was they came back about 6 months later and had a working tool. A year later, we had this incredible product. The main thing for me with this is it had to be super intuitive. I didn't want the guys to have to relearn their trade. You know, they're designers, they're sketching all day with a pencil or a pen or a Wacom stylus. I wanted them to carry on with that knowledge and that skill set, not have to do Control-Alt, F5 and so on. That would have killed their creativity. So that's what we've delivered. We launched it about 18 months ago at this Hong Kong Innovation out in China, and it went down really, really well. Neil now, the guy with the power jacket, he's now set up a business around it, so it's his company now, and he's now developing it further, adding more value to that tool. We're both working together on it occasionally. We get together and catch up. It's super powerful. It makes me really proud. We're the first design studio in the world where every single member of our team has got this tool on their desk, and it's really empowering the designers, and it's speeding up the process. This is just a quick sort of snippet of how it works. What I wanted, I used to see the guys literally throwing a line, sketching a line to get the natural sort of tension and snap to it, you know, over a vehicle center line, and I'd see them sketch it, undo it, sketch it, undo it, and on and on and on. With this, you throw in a line, it gives you minimum control points, and you can just tweak them and modify so you can get the sort of snap and the tension in it exactly where you want. You can switch on and off the hard points, so there's no cheating. So if an engineer comes in and says, yeah, you brought the fender right down there, that's never going to work. You can say, actually, it will, because the radiator's not sticking through it. It's all on package. So it works really well. This has really, really, really empowered the guys. And you can see, even from this is not speeded up. It's not fast forward. Something that typically would take days, even weeks, to come up with a volume model in 3D. Literally, you can do something in 10 or 15 minutes now. It's making it a big change to the way we design cars. So, and it's a great example of our be brave, you know, don't stand still. So there's a finished volume model, basically. This is where we can really understand, where you spin it round and you think, yeah, it looked really great in 2D, but actually the rear deck is not working well, or the front's not looking so good. And it really, at that stage, you can start to really analyze the model and start to diagnose where the problems are, where the issues are. So, on the interior, we started off a few years ago with, I would say, the world's most rudimentary seating buck. A few bits of MDF and a bit of plywood, steering wheel, but a proper seat. And then with a headset, an Oculus or a Vive or something like that, we're not really too concerned about the specific makes of them. It's just something where you can have the volume around you of the interior. So as far as that guy's concerned, he's inside the car. And that's something I think is really important from my perspective, is I don't ever want any of the designers to be thinking about anti-aliasing or frame rate, or we heard it a little bit with the panel in the last sort of 10 minutes of their discussion. It drives me crazy if anyone reacts like that. All I want them to do is put on a headset, immediately forget about it, and look at a car and tell me what's wrong with the design of the car. That's the key to it. It's just a simple tool to be able to diagnose whether you like what you're seeing or not, and basically make good design decisions. So I feel that's my job, is to give them these tools with no distractions, basically. It's all about confidence, basically. The two words I always talk about are confidence and believability. That's what I want the users to get out of using these tools. We've got something a bit more sophisticated now. This you can modify in X, Y, and Z. You can change the positioning of the footbox, steering wheel, and so on. So we can basically electronically configure this to whatever vehicle you're working with, and then we can augment around it in VR, all of the geometry, basically. What you can do now, which is really important with this, we can start to bring in physics data, we can bring in different percentile figures. So Stephen sitting in the buck here, he can actually understand what it's like to be 5 foot or 6 foot or somewhere in between. We can bring all real-world data into this buck. And again, you can start to make really good design decisions. And also, this is virtually drivable. So You can drive down the street, it's static, it ain't going anywhere, but you can drive down the street in it in your VR world. You can see if there's blind spots behind you. You can understand if the A-pillar is obscuring your view. You can get all sorts of great information out of it in the early days, before we've committed to tens of thousands of pounds worth of physical models that we used to spend a fortune on. We still spend a lot of money on physical, but this is starting to really benefit us now and save us money. So the physical models, this is where I would say the craftsmanship and the technology come together. We're CNC machining using the CAST software. We start off with 40% scale models, and then we go to full size when we get to a single theme. But we CNC machine it all in. In an ideal world, we'd all stand back and look at that model and go, that's perfection, and then we can all go home because our job's done. But that's never the case. We machine something in, and you stand back for the first time, look at a full-size model, and you think, you know what? You need to take a little bit of material off here and a bit here and a bit here, maybe put a bit of clay onto here and do this. And that's where the craftsmanship comes in. We've got a great team of clay modelers. They're sculptors, basically. We have ovens in the studio that are keeping the clay warm. They can go in, they can get clay, they can throw it onto the car, they can start to scrape it around. And they have these beautiful tools that they make, like dentist's equipment almost. And that's the real craftsmanship. They'll work with the designer, and they'll look at just hand and eye kind of skills to optimize that surface. We'll only do it on half the car, and then we'll scan it, get cloud data, give it back to the CAST person. They effectively trace it, and then so the process goes on, and we just keep optimizing and optimizing to get it better and better. Then we put this material called Dynoc on it, and these are all the things that I'll get to in a moment, in that we're now replicating in the virtual world, but it's replicating how we do it in the traditional manner. We use a silver Dynoc because silver shows off the sculptural nature of the car better than any other color. It might look cool in black, but you just read a flat surface. In silver, you can read every little nuance and subtlety and the kind of muscle tone of the car. So that's how we do it. We take the car outside, and this isn't a real car. This is 2.5 tons of solid clay, pretty much. But it works really, really well. We'll park it next to a couple of benchmark our own cars or competitor cars, and then we can get a standing back, say from where I am to the screen, is the right sort of distance to just feel the essence of it. And you can see all the sculptural nature of the body side there. You can just read it instantly. You need a blue sky, like out here. In the UK, it's not always so good, but on a grey day, it doesn't work so well. But we want to stand back from the car. We want to be able to read all of those surfaces. And then we still might put some tapes on them and modify them and change them slightly. But essentially, that's towards the end of the process. So in parallel with that, we do this. We're now starting to get really, really good value out of this. We can virtually validate as well. I think we all know human nature is, naturally, you want to touch and connect with a physical property to really understand it. And I'll get onto that in a moment as well. At the moment, we get huge value out of this, and the next step will be haptic in this environment. But this is working really, really well for us. And what we're also starting to do now, so this is VR. We're also starting to use some spatial computing as well with our friends from Magic Leap, and we can augment over the top of the physical models. So what we can do now to start speeding up the process is, rather than having the clay modelers put in theme 1, spending a day, theme 2, spending a day, don't like that, don't like that, don't like this. We could spend a lot of time doing that. We can now overlay the virtual model over the top of the physical base model, and we can quickly go, don't like that one, don't like that one, don't like that. Whoa, that's a good one, let's keep that. So it's, again, adding a lot of value and speeding up the process. So I just threw this in as a, don't read too much into all of the names of who's there and who's not there, but it's just to give us an understanding of, in my opinion, it's really important to support everyone out there today, everyone else who's not here that we know of, suppliers, startups, established companies. I think it's so, so important to get out and communicate with these guys, help them with their products, help them develop them. I think all of us in industry, it feels to me absolutely essential that we support them and we make their products better. You know, some of them have already delivered and they're going to go on and improve those products and make them better and better. There are others out there that have not made it, you know, and may never make it, but we have to go through that process. And I think it's absolutely vital to give them real-world feedback, road test the products for them. And that's what we try to do as much as possible, and it's definitely gaining results for us. The other thing as well, the other thing on that last slide, what I think is super important is I don't necessarily go to just automotive companies and suss out what they're doing or find out through the grapevine what our competitors are doing. To be honest, I'm not even that interested in that. I'm much more interested in, for me, in automotive, I'm interested in what the medical world's doing, what the medical industry's up to, architecture. The last panel, there's some interesting comments, what the games industry's doing. I think it's much more, it sounds crazy, it's almost more relevant to listen to what those industries are doing and think, hang on, they've got a tool that does this. Maybe we could use that in our world and start to mix it up a bit. I think that's super valuable. So, customer experiences, enhanced driving. I've experienced some of this already. It's a long roadmap, but starting to augment the real world with a driving experience, keeping your vision as clear as possible, but having specific information appearing for you. We work with some of the best race drivers in the world, and to make you a better driver on the track and then a safer driver on the street, we can give you different bits of information, and we're able to, or we will be able to start augmenting it in a production manner to give you an even more improved driving experience. That's, for me, that's super exciting. So watch out on future products for that. HMI I talked about a little bit earlier. We want to keep the cockpit of the car as, I like the word serene, as serene and minimalist and visually uncluttered as possible, because it's all about the visibility and the confidence of driving. Now, though, in some of those bucks, in that latest digital buck that I showed you, we can now start to project HMI displays and so on in that world as well, so we can start to test them in the virtual world before we start to build them into, or spend a lot of money and build them into prototype vehicles. So that's another way we're getting good value from that buck. And again, using the physics data that we're getting, we can actually test stuff in there too. And I spoke about this earlier. We're working with these guys. I've seen there's some other people out there today I've been talking to. These guys are delivering something I think really quite special, and this is literally another dimension in the VR world. You've all seen it, and you've seen different versions of this, but I think this is going to make a big difference. And like I was saying earlier, the first thing anyone wants to do when they see something beautiful, a sculpture or a vehicle or whatever, is you want to go up and touch it, and that's missing at the moment. And we're not using this as a tool yet, but I can see this or something along these lines is going to, when they deliver, it's going to be so valuable to the whole virtual experience. Yeah, it's a really exciting time. It's going to transform the way we interact with the virtual world. Here's just a quick movie just to show you. We created a VR experience using this geometry, but this is just a screen version of it. This was like an educational tool for our customers and prospects, where at events they could put on a headset and they could stand in a virtual wind tunnel. They could use the hand controls and they could actually start to squirt the smoke into intakes, and it would give you information of how much more efficient this was than the previous car we did. It would tell you how the air brake operates and gives you more downforce. It was a really powerful tool, and we got a lot of value out of that. And this is where, is this going to play? This is where we're spending time now. This is just a screen version of this, but we're now using this with our Magic Leap friends. We're using it in VR as well. So it's starting to add a lot of value. We build this in-house. We use Unreal Engine. It's the best tool for us for visualization, but because it's open source, we can build our own tools, which is making us really quite flexible now. We can do these sections, we can measure stuff, and specific things we need that we can't buy off the shelf from software suppliers, we're building them ourselves now, and this games technology is really changing the way we do things. Like I say, this is just an example of it on screen, but when you're actually in there with a headset on, this is so powerful. It's just brilliant for us. So the ergo designers at the early stages and our designers can really start to interact with this, whether you're in the car, out of the car. We can make notes, we can, we've created all of these things. And to be honest, I have an ever-expanding list now where even the people that weren't so interested originally, thinking, well, we already have tools that we can do that with. Once they've tried this, they come back with a huge list saying, can I have this? And can you give me this and this and this? So it's all on the hit list now. And we're able to do it, which is the really, really cool thing. We only got a small team, but I've managed probably a bit of luck and a bit of judgment to find people that are kind of flexible enough and good enough and enthusiastic enough that we've got the creative guys, but we've also got the more kind of geeky developer guys as well, and we just pick the right people and they'll go away and do this. And I think one of the advantages with McLaren, we're getting bigger, with 3,500 people now, but we're still very, very agile, and if we can show a product delivers and adds value and saves money, which is the key thing, then it becomes part of the process within weeks, whereas we don't have to go through all the hierarchy that some of the big OEMs, big organizations do. So we're very lucky in that respect. Right, this is at the other end of the spectrum. It's just an example, again, just a screen version of something we do for customers. We've now got real-time ray tracing working. We've got really high quality, high fidelity visualization images. So for the customer, they can see exactly what their car is going to look like. They can configure it how they like, and there's no surprise when they come and pick it up, because that's absolutely not what we want. We want to keep the customers happy. We're very good at the whole thing at events. That goes back to Formula One, and we start to use these tools now at events. They're going to be available online soon. All of the dealerships have a similar product, not quite to this level yet, but it's going to go out very, very soon. So that's kind of it, really. What I would say is, we're getting great, great value from the technology today, from the things you're seeing at this show and from other events. We're building more and more tools. We have a big hit list of stuff where we're going to add even more value. I see it as a win-win situation. If we can speed up the process, which we're making good progress with, saving money, and saving time, basically, but maximizing the creativity, then it really is win-win. If the financial director's happy as well, then that's got to be a good situation for us to be in. And so far, we haven't had any complaints. So thank you for your time, guys.